buongiorno, that's about, like, I only know very little Italian, so I can't do a nice Italian introduction like Frederic before me. My name is Birgitta. I'm from Germany, actually, and I am a programmer. I have been for about 15 years now. I learned my first language 15 years ago, and I've been doing this professionally as a software developer for about 10 years now. And I'm still programming today because I'm fortunate enough to work for a company that believes very strongly in coding architects. So although I'm now in more tech lead type of roles, I'm still programming almost every day. And I'm assuming that a large part of you in the audience are also programmers or aspiring programmers or people who work with programmers. And what I want to talk to you about this morning is the images in our heads about what or who programmers are and how we would complete the sentence. And I personally try to complete the sentence more or less subconsciously, I guess, in some way a lot when people ask me, what are you doing for a living? Or when I interview prospective new software developers to work for ThoughtWorks, or also with regards to my own identity. And to talk to you about this, I want to start with some history. Because I recently learned a lot of things that were new to me about the history of the programmer profession by reading this book, The Computer Boys Take Over by Nathan Ansmenger. And Ansmenger is a professor at Indiana University in the US, and his specialty is the social and historical aspects of computing. And his book covers a lot of different aspects, like including the beginning of computer science and how it got its name, and when software started disrupting organizations, when we had the first explosion of languages, like I guess, you know, we have over time a lot. And so on, but what I want to summarize for you a bit is Ansmenger's description of how the term programmer was first defined and who the first programmers were. And what I found interesting about this part of the book is that it seems to close a gap in computing history, at least as far as I knew it. So this is a screenshot from the website of the Heinz Nixdorf Museumsforum in Paderborn. Paderborn is a city in Germany, actually very close to where I come from. And they claim to be the largest computer museum in the world. So it's not in California. Apparently it's in Paderborn, which is quite a nondescript city in Germany, I would say. And you see a few of the areas they cover here. It's all about hardware, technology, again, how software disrupts society, languages. But the gap that Ansmenger wants to close in this part of his book that I'm talking about is the history of the majority of the people writing software and the profession and the mainstream culture around that. Because when people think about software creators, they often think of these guys, right? More like inventors and entrepreneurs. And some of you might know that two of these guys are not even programmers, right? Or another image outsiders might have is this one, kind of the hacker wizards who can do anything with computers and, you know, crack polymorphic algorithms to access a terminal, apparently. I don't even know what that's supposed to mean. But these are not representative at all of the vast majority of software developers, I would say. I don't know if any of you actually identify with these images. So if we're talking about the origins of the programming professions, we kind of have to start with the people who are by many considered to be the first programmers. And that's already where it starts to get a bit difficult, because when you Google first programmer or erster Computer, which is first computer or erster Computer, which is the same in German, you can already see that the Americans and the Germans are kind of not maybe of the same opinion what the first computer was, yeah? So Germans think maybe Konrad Zuse built the first one, but like a very common story is that the ENIAC was the first digital computer, and both sides, you know, have their arguments, and I guess both of these were kind of the first real digital Turing complete machines. This is actually a reminder that the research I did for this talk was very US-based. Yeah, of course, through my German glasses and perspective, but I think it's okay for the purpose of what I want to say, because the US is still shaping our profession, our industry to a very large extent, but it's still maybe something to keep in mind that this is very US biased. So the first programmers of the ENIAC were the ENIAC girls, or women, as I like to call them. Who has heard of them? Anybody? Only very few show of hands. But they've actually become a lot more present in the media over the past year, I would say, but maybe that was just my perception because I was reading a lot about these things. And the ENIAC women were the ones who programmed this computer, and the program they wrote was, its goal was to calculate the trajectory of weapons. So kind of to create tables for soldiers in the field to look up like how they would have to shoot so they would reach their target. And I'd heard about them before I read Ensminger's book, but when I started reading up even more about them, I became really fascinated by them. And I just have to show you this short interview with one of the ENIAC women, Jean Bartik. She's the one on the left here. And I took this video from the other big computer history museum, the one in Palo Alto, I think. And let's see if we can get the sound to work. Okay.
Betty Snyder and I, from the beginning, were a pair. And I think, I don't know, many of you work technically, but I believe that the best programs, the best design, and all this stuff is done by pairs, because you can criticize each other and, you know, find each other's errors and use the best ideas, and it really works very well. Later on, I have thought about why did Betty and I become so successful, and we were successful. And I think it's because we were finishers, because most people like to do the fun part of a design or a program, but they hate doing the nasty little details that usually take more than the middle design. And so you have to take care of everything and think of everything so that it works. Well, I was good at it, but Betty was even better than I am. She was fantastic.
A quote from Betty Snyder Holberton.
Oh, yeah.
Look like a girl, act like a lady, and work like a dog.
Wait a minute. You skipped a line.
Oh, I skipped a line. What?
Think like a man.
Oh. I don't know, though. I think you all were doing some great thinking there. Great thinking.
The smartest thing we did was to have Marlon and Ruth calculate a trajectory exactly the same way the ENIAC did it, you know, add time by add time. Well, this is the document that made people respect us. Because of those 18,000 vacuum tubes, we could find the one that wasn't working in a very few minutes with that. And we were never, people never recognized, they never acted as though we knew what we were doing. I mean, we were in a lot of pictures, but they never asked us anything. Well, we did all the programming for it. I mean, it was absurd.
So this woman, Jean Bartik, she's talking about the 40s, yeah? And she's talking about pair programming. And that just blew my mind when I saw that video. It's like the first programmers, they already practiced pair programming, and it took us 50 or 60 years until that became like a well-known practice in our industry to get back to that. So that was really amazing to me. And also in the second part where she talks about how this other pair of women, they calculated the trajectory by hand. So actually all those women, they were, before that, they were part of a group of women who would always do this manually because they didn't have a machine for it yet. And these two women would kind of calculate the expected outcome, yeah? And then they would compare it with the actual on the ENIAC, and that's how they found the errors. So also very close to like a very basic concept that we use all the time when we do testing. So I found that quite amazing. Yeah. So as you can see, up here is like a little video without sound. This is actually Jean Bartik back then. It was a much more mechanical process at the time, very switchboard-like, and the term programmer, of course, didn't even exist, so neither did the concept of a program. And Jean and the others were called computers or operators, and it was considered more handicraft and science and more mechanical than intellectual. And the interesting thing is that Ensminger says they were also called coders at the time, and this became a term very associated with this mechanical or manual work and also with the female gender. And he says that even shortly after that, when the term programmer came around, for decades, like the term coder still had a negative connotation because of this and male programmers tried to distance themselves from it because it was kind of supposed to be this like more manual, less intellectual female work. So now I like to call myself coder even more than before. So the hardware was continuously improving, and a lot of people were excited about the progress and the bright future of computing. And but there's this myth, kind of like, that people didn't see this coming, right? But like, did they really not see it coming? This is a still from a German TV show called Space Patrol Orion. It actually aired around the same time as the first episode of Star Trek in the US, and my mother used to watch this when she was a kid. And I think it's quite clear that people actually had very high hopes for computers and what they would be able to do, and or for pressing irons for that matter. So interesting stage design here at the time. So people were having very high hopes, but they weren't actually paying much attention yet to software in like the 40s, 50s, 60s. They were focusing very much on the hardware, and yeah, software, this is something additional that you do. And this is Steve Shirley. She's a British woman who founded one of the first software companies, or startups, you could even say, in 1962, with a workforce that exclusively consisted of women working from home. And she says this: software was given away free at the time with hardware. Nobody would buy software, certainly not from a woman. But it soon became clear that the challenge of software development, that they had really underestimated that. And they kind of hit this unexpected wall. And I will give you a bit of time to read this quote. So this is Maurice Wilkes, a British computer scientist, and he says in his memoirs he realized, you know, I'm going to spend a lot of time finding my own errors because this is actually quite hard and error-prone. And there were lots of stories in the press in the 50s and 60s around how programming is error-prone. One example is that of the Mariner 1 probe to Venus. It steered off course, and they had to destroy it. And there's like a few legends around why that happened. One of them is that there was a dot instead of a comma in a Fortran statement, and that's why it happened. It's like more of an urban legend, probably. One of them apparently means looping, and the other one is assignment of a variable. I wouldn't know, I've never written any Fortran. But it's highly debated if this really was the error, but it shows the type of stories that were going around, and it led to the belief that it strengthened the opinion that you should only use the most skilled programmers. At the same time, the demand for programmers like skyrocketed, really. So you need very good people. You really don't have any idea yet what they're supposed to do, and you need a lot of them. So the view of programming in the 50s and 60s was kind of that of like a black art. The programmers have to be born, not made, because they couldn't quite figure out the skills that you need to be a good programmer. And then there's like a famous quote from IBM from the 60s: when a programmer is good, he is very, very good, but when he's bad, he's horrid. And I think we still hear that around today. So it was quite a crisis. Some of you might have heard this term before, software crisis. It came around in the 60s as well as a term to describe the crisis that you need a lot of people to do this work. You also want a lot of good people, but you just can't fill up the pipeline and get those people and figure out how to get them. And it's actually still going on today, since the 60s, I would say. So they identified the growing need for programmers, but what kind of training, what kind of abilities would they need? So this is a job ad from IBM in the New York Times, Scientific American, LA Times. Those were kind of the papers they published it in. And it says, "Are you the man to command electronic giants?" And then in the description, it says things like, they're looking for candidates who enjoy musical composition and arrangement. They should like chess, bridge, or anagrams, or simply possess a lively imagination. And they got 7 answers on this ad, and they considered this an excellent return on investment, which kind of highlights the very peculiar nature that this emerging profession had at the time. And the solution the industry came up at the time to identify and recruit were aptitude tests, for example. So kind of filter for traits that they thought essential to good programming, such as logical thinking or abstract reasoning, things like that. And by 1962, an estimated 80% of all businesses that needed programmers used some form of aptitude test when hiring programmers. And half of these actually used the IBM PAT, or PAT, the Programmer Aptitude Test. And it would become the industry standard instrument for this aptitude testing. And in 1967 alone, 700,000 individuals took this same test to identify if they would become a good programmer or not. So it was basically the gateway into the programming profession. And it had three parts. The first one was about completing a number sequence. The second one about kind of geometric comparisons. So you have some shapes, and you have to say what's the one that's missing out of this list. And the third one was kind of high school mathematics little problems to solve. So it sounds a little bit to me like TAS and like intelligence tests, or what's around still today. And there's actually no proof that the scores that people had in these tests actually corresponded to their performance as programmers. A lot of companies didn't even care to check, and the ones that did, they got very ambiguous data, so they never found any real proof that just because you had a high score on this test, you would actually also become a good programmer. So, but many people thought this type of testing was not enough, so they also turned to personality profiles. So there was this paper in the 60s, a vocational interest scale for computer programmers. And when I read about this, I did not know what vocational means. So apparently it's kind of like your aptitude for a certain profession, your kind of calling. So when you go to like a job center as a young adult and you ask them, you know, what do you think might be a good job for me? And they kind of do some testing with you, and then they say, oh, you seem to be somebody who fits a personality profile, so you might like to be a nurse or a doctor or something. And so they tried to define the scale for programmers as well. So what did they come up with? They said programmers are crazy about puzzles. They tend to like research applications and risk-taking. They dislike routine and regimentation. And the fourth one, my favorite, they don't like people. So most of these were actually, there were more of these actually, and a lot of these things were very close to the vocational interest scales for engineering and chemistry, not even that close to physics or mathematics. And there was a slight correlation with musicians. But otherwise, they were pretty similar to other white-collar work professions. But this striking characteristic, disinterest in people, this is what they came up with exclusively for the programmer profession. So, and then this paper was accompanied by these kind of ridiculous little cartoons. I don't know why. Like if the authors weren't really taking their work seriously, or so here's the guy who likes puzzles. Here's the guy who likes risk-taking. Research applications, and here this grumpy guy is the one who doesn't like people, apparently. So you're laughing about this, and I was laughing about it as well, and then I read on, and I read about, you know, in which context this paper was written and what it was used for. So the authors were paid by a company called SDC, and IBM hired SDC in the 60s for the programming of a project called SAGE. And of course, it was yet another military project. Semi-automated ground environment air defense system for the US Air Force. But, so what it was actually doesn't matter this much for my point, but by 1956, this company, SDC, was employing 700 programmers. Those were 3/5 of the available programmers in the US at the time. And by 1961, they had hired 7,000 more programmers. So they kind of said of themselves, we trained the industry. And for the next decade, almost every department in the US that needed programmers, you could find an alumnus of SDC, very probably. And actually also most of the study subjects for the paper worked for SDC. And SDC also originated that aptitude testing approach I showed you before with the logical tests, and that then spread through the industry. So, surprise, yeah? 700,000 individuals took the same test to determine if they would be good programmers. the company that trained the industry chose their employees based on a personality template that included, you know, programmers don't like people. And of course, now that programming turned out to be quite a demanding intellectual job, it could not be done by women anymore, obviously. It's the 60s. I don't know who of you watches Mad Men, yeah? So you see what I'm getting at, yeah? So Ensminger is concluding in his book that these hiring practices resulted in a primary selection mechanism for antisocial, mathematically inclined males, and then it kind of became a self-fulfilling prophecy. And I have to say, it makes a pretty convincing point, and the public image of who a typical programmer is supposed to be like, well, it hasn't changed that much, right? At least the public image. So we're still having kind of trouble with our image, like how we're seen from the outside as programmers. You know, we're supposed to be all these, you know, guys sitting in a basement not talking to anybody eating pizza. And I hope that we agree that things have changed, yeah? I hope nobody identifies with this grumpy guy. And we all know that our jobs require a lot of communication with people, and it's a lot more than just puzzles. And I'm also not saying that we should shut out everybody who fits this profile, God forbid. I'm just saying that there's way too much focus on it, and it kind of leads to the self-fulfilling prophecy that also maybe puts off people who are different from that to even start working in the industry. So, but I'm still asking if we are maybe still expecting subconsciously real programmers to be like this. And on the flip side, are we expecting people who are not like this to not be real programmers? So I want to look a little closer into the images of today. And it's interesting to look at these views from the 60s again and compare today, because, you know, black art, I definitely think that is still a perception, especially for people outside of the industry. And this magical being, the good programmer, who can apparently be at least 10 times as good as the horrid programmer, yeah? And at the time, maybe it was even more true than today, because for a while, every machine had its own little tricks to get around, and before compilers and other tools came along, it was a much more tedious affair than today. And the software crisis has basically been going on since then. But let's see what this persistent image of the programmer profession might do to people who are just starting out. And I want to show you another quote and give you some time to read it. So I got this quote from this book, Unlocking the Clubhouse by Jane Margulis and Alan Fisher. And it came out in 2002 actually already. And what they did is they did interviews with computer science students at Carnegie Mellon University in the US, one of the elite IT universities right there with MIT in the US. And they conducted those interviews over the course of about 6 years. And they had, in the group, they had a 50-50 gender ratio, and they asked them questions like, why did you choose to study computer science? What motivates you to do this? How do you feel at this point in time? Some of them dropped out, so they asked them, why did you drop out? And there are lots of quotes in this book that can give us an idea of what the images in our heads of programmers might be today. And I want to show you 2 more of those. So these kind of show this, this image of like a single-mindedness that you have to have, like do this all the time. You know, it's not just your job, it's your life. And these quotes are not all from women, by the way, just to say that, but it's kind of this, if you are not totally focused on this and single-minded about it, then obviously you can't be a real programmer. Maybe, you know, this is not for me, I guess I think I'm more balanced. And they see this eat, sleep, code repeat attitude, and they think, wow, that's passion, yeah, but I'm not like that. Like, maybe tonight I want to read a book, or I want to go out with my friends and talk about something else than computers. So I guess, and then they think, so I guess I don't fit in as well as I thought I would. Maybe this is not the right thing for me after all. But there are two sides to that, right? So for some people, that same behavior might be seen as obsession. And so this, I guess, I think I'm more balanced. I'm not saying that it's, I don't want to say that it's a bad thing to have this single-mindedness or to sit on your computer all night, but it's just something that we seem to equate with, you know, you have to do this to be a real or a good programmer. And the book describes an exchange between two high school teachers that I found very eye-opening, so I want to repeat it for you a little bit. So there's a male high school teacher and a female high school teacher, and the male teacher writes to her in an email that he comes across a lot of boys in his classes who really love computers. And several parents tell him that they just, you know, if they could, they would just stay on their computer all night and program if they could. And the male teacher says, I have yet to run into a girl like that. They look at me funny when I talk about programming as fun. And then the female teacher responds, and she's not responding and trying to give reasons why girls are not like boys, but she says that maybe there's a misassumption that he has, so that he's looking in the wrong places for signs of people being interested in computers or his students. So, for example, staying up all night programming, apparently if you don't do that, then that's a sign that it's not fun for you, yeah? So, and the other way around. But she says that girls may show their love for computers and computer science very differently. So if we are using a single model to identify potential programmers, we will miss many potential students. So I found that very eye-opening when I read that. So do you also have a scale like this in your heads and you don't even realize it? So that would be my question for today. And what does it do when you are interviewing candidates to work with you as programmers, or when you are describing to other people what your job is like? And also, what might it do to some people's identity? This is a blog post on Medium by a woman called Erica Joy Baker. And she's describing what working in a homogeneous environment like this can do to a person when they feel like sticking out like a sore thumb all the time, kind of like a low stress level every day because she kind of feels different. And she's been working as a programmer for 10, 15, maybe even 20 years. I'm sorry, I don't remember the exact number, but she says things like, I continue to lose myself for the sake of being included amongst my coworkers. And this image caption actually says, at work, wearing the uniform. And by uniform, she's referring to jeans, unisex t-shirt, and sneakers. And she's also concluding that she feels like she's lost her entire cultural identity in an effort to be part of this industry for a decade. And I can only recommend you read this. So it's called The Other Side of Diversity, and it was really something that I had never thought about it in this way, and also quite eye-opening. I really admire her for sharing this because it's a very personal story. And fortunately, nothing this drastic has happened to me, but reading Erica's story made me think back and reflect on this, like how much maybe I have subconsciously adapted because I was always in the minority as a woman in like all the teams that I worked with. And I can definitely relate to some of the tendencies and little situations that she's describing. And for example, I realized that I've often tried to emphasize those parts of me that fit this image. For example, I'm really into science fiction and fantasy, so I've always been very keen on, highlighting that. And on the other hand, maybe just stayed more quiet about the ones that don't. So many times I've sat at tables with my male colleagues and they talk about their first computer, and I'm like, yeah, my first computer was had Windows and I played Tetris on it, yeah, so. So, before I finish, I want to ask you for a few things. The first one is, don't think the status quo is, just natural. It's just like somehow men are maybe more interested in programming than women. And I mean, obviously, I focus very much on gender here because that's my personal perception, but of course there's a lot more diversity dimensions in our industry that we're not very good at. So something that I always wondered about, for example, is I was actually having discussions with people. Why is it that such a majority of programmers like science fiction and fantasy? Like, what's the correlation between, you know, liking programming and science fiction? And now I'm like, oh my God, you know, there's no correlation at all. It's just self-selection, you know. We're just hiring people over and over again who like that because we think that belongs together. So don't let a few guys in the 60s still determine who we hire and how people perceive us. Let's break that cycle of hiring ourselves. The second one is stop acting so surprised. Who here has heard of the term microaggressions? Only very few hands, actually. So it's this idea that, you know, you don't look like a programmer, yeah? Or I recently had a conversation with a journalist, actually, doing a documentary about programmers. And he was asking me, so what do you do at ThoughtWorks? Did you organize this event? And I said, no, I'm a software developer. He was like, oh, wow, cool. And then he asked me, so does that mean you also write code? Or and I was like, dude, you're doing a documentary about programmers. You should know what a software developer does. But anyway, so, but microaggressions means that, you know, it's like a small thing. And I know he didn't mean it, and, you know, but if somebody who sticks out like a sore thumb and isn't, and also starts thinking, maybe I don't belong here, maybe I'm not as passionate about it, and then they hear over and over again, oh, you don't look like a programmer, oh, you know, I'm surprised you do this, you know, then after a while, they might start to believe that that's actually true, that they don't belong and they don't look like this, so they might actually drop out. So stop acting so surprised, like avoid incredulity, like, what, you've never seen Star Wars, or, you know, these types of things, because don't make assumptions about what people might like or not like or do just because they are in this profession. And it seems like small things, but it's actually interesting to try and listen to yourself when you say these things. And finally, yeah, challenge the vocational interest scale, like the image of what the real programmer. Yeah, so let go of the notion that only people who spend every free time programming can be good at it. Because let's face it, no amount of time today, you know, can get us up to speed on everything to deal with today so that we can do it by ourselves. So with developments like DevOps, microservices, and all those things, you need a really broad set of skills. Or if you work in an environment like me, where you're expected to be a full-stack developer, to do front and back end, be good at communicating, leading a team, write test first, own your craft, all those things. It's a black art indeed, just very different from the 60s, and we can only succeed at it in teams, and we don't have to, just got distracted. Yeah, we don't have to do that all by ourselves. So I'm almost done. I want to leave you with these images. This is actually a representative excerpt of the faces of the programmers that I've directly worked with on a team in the past 3 years. And 1/3 of these faces are women. And actually, all of the projects that I've worked on over the past 3 years, at one point, we had a 50% gender ratio among the developers. Of course, every team I am on has at least one woman, so it's more probable. And there might also have been some other type of self-selection involved in this, but I just want to tell you, you know, it is out there, and I know that it's uncommon, and I feel very fortunate to be in this environment. And I never thought I minded working in all-male teams. But since I've had it in a different way, I'm like, I didn't even know what I was missing. And you might not know what you're missing as well. So, and I'm not showing you this to brag, because ThoughtWorks certainly hasn't got it all figured out, but just, you know, it is out there. Yeah, so this concludes my little book club, yeah? And I will tweet this slide after the talk under my Twitter handle. So, and if you ask me, like, if you should read one of these 4 books, it would be this Unlocking the Clubhouse. It's really quite eye-opening. Thank you.